Good evening, Honors Algebra. Mr. Lawrence here with your flipped lesson. I'm going to honor my promise so that Quinn doesn't get upset at me. I think this is going to be a really short video. We're going to deal some more with negative exponents and quantities like we did in class a little bit. So let's get a little more practice with them. In fact, I'm going to do one, and I'm not going to do any more. I'm going to give you the problems, and you're going to try to do them. Okay? Because that's the only way you're going to get better at these. All right, so let's say example number 1. Before I do example number 1, let me go off on a small tangent, James Bollinger, but it's actually a relevant tangent. Let me ask everybody what 5 to the negative first power is. Let's see here. 5 to the negative first power. Well, if you all recall, that should be 1/5. And I know that bothers some of you. If it bothers you, please do this. 5 to the third equals 125. 5 to the second equals 25. 5 to the first equals 5. And then remember from previous video, I divide by 5 to move down the column. So therefore 5 to the 0, I must divide 5 by 5. I must get 1. 5 to the negative first, I got to divide by 5. Oh, that'd be 1/5. So 5 to the negative first is 1/5. Okay. A negative exponent means to use the stairs. Ooh, I missed my negative there. I have to fix that or Andrew will tell me all about it. By the way, I hope your teeth are feeling better, Andrew. All right, so if I had a problem, say like 3 to the negative fourth, well, I know that 3 to the fourth is 81, right? Well, 3 to the negative fourth would be 1/81. Okay, so now that we have that understood, let's look at example number 1. Excuse me. I have the quantity of 5x to the fourth, y to the negative second, z to the negative third. That'll all be over 12 x to the negative second, y to the negative eighth, z to the 10th. And I will raise that quantity to the negative second power. All right, well, like I said in class, the first thing I'm going to do is simplify the inside of the quantity first. I'm going to look at the 5/12. That's not going to simplify, right? I am going to take this guy and move him upstairs with the positive exponent. That'll be x to the 6th. Okay, if you want to think about it as division, it'd be x to the 4th minus -2. Minus -2 is a plus positive. All right, these guys will flip places and change signs. So in the numerator, I will get y to the 8th. In the denominator, I'll get y to the 2nd. But I also know that that can simplify a step further. That will cancel out, and that'll turn into a 6. I'll rewrite that for you in just a minute. All right, this guy here will take me downstairs, so I get z to the 13th. That is all still raised to the negative second power. Now just to make it a little bit cleaner, 5x to the 6th, y to the 6th in my numerator, 12z to the 13th in my denominator. Now, oops, not -12, excuse me, just -2. All right, I've got a -2 here. Now, that negative exponent, remember, a negative exponent means to use the stairs. The numerator becomes the denominator. So what I like to do at this step, so I don't make any silly mistakes, is I like to flip my fraction, use its reciprocal. Oh no, I'm not in right mode. 12z to the 13th in my numerator over 5x to the 6th, y to the 6th. And now that's raised to the second power. Because I didn't do anything with the 2, I only did something with the negative. I flipped the fraction and therefore the sign changed on the exponent. Now I'm ready to evaluate my fraction. Excuse me, to apply the exponent. So I have 144 z to the 26th power. Think about it. I have 13 z's being multiplied, and then I have 13 more z's being multiplied. Altogether, I have 26 z's being multiplied. It is not 13 to the second power. There's 13 of these guys, and then there's another set of 13. That's 26 z's altogether. Okay, the denominator, 5 to the second power, 5 times 5 is 25. And x to the 6 times x to the 6 would be x to the 12th. And then y to the 6 times y to the 6 would be y to the 12th. And there you go. And that fraction cannot be simplified any further because I did all my simplifying first. Okay, so let me see how I'm doing on time here. Oh, this is good. I'm only at the 5-minute mark. All right. So here's an example for you. example number 2. I want you to try it on your own. And let's go with 16 x y to the negative 8 z to the 11th over 12 x to the negative 4th y z to the 15th. And we are going to raise that to the negative 3rd power. All right, go ahead and pause the video. When you're done pausing, you'll watch and see my solution. All right, so if you're watching at this point, I assume you're ready to see. The first thing I'm going to do is simplify my fraction. And I know I can divide by 4 there, divide by 4 there. And so my new fraction will have a 4/3 in it. Okay. I've got an x to the 1st and a negative 4, but this guy's going upstairs. So in the numerator, I'm going to have an x to the 5th. All right. I got a 1 there. That's going to take me downstairs. So in the denominator, I'm going to have a y to the 9th. And then if I had z to the 11th over z to the 15th, I don't like to do the subtraction way because then kids get screwed up where it's supposed to go. I see 11 z's in my numerator. 11 z's in my numerator. Can you visualize that? I see 15 z's in my denominator. I'm going to cancel them. There's going to be 4 z's left, but they're still in the denominator. Okay? That's not the only way to do it, but that's the way I like to think about it. Negative 3rd. All right, so now I'm going to get rid of the negative here by using the reciprocal. Theory y to the 9th, z to the 4th, put it over 4x to the 5th, raise it to the 3rd, and now I'm going to raise everything to the 3rd power. 3 to the 3rd, I believe, is 27. Y to the 9th times y to the 9th times y to the 9th. Y to the 27th. Z to the 12th. Okay. 4 times 4 times 4 is 64. X to the 15th. Now, just a little side note here. If you got this for an answer, 27 y to the, I don't even know. Let me pause the video and figure it out. 7/29th power, I believe it would be. 7/29 z to the 64th over 64 x to the 125th. If you got this answer, your exponents are all wrong. You are raising this exponent to this power, and that is not correct. You need to think about this part right here. Y to the 9th to the 3rd. It means y to the 9th times y to the 9th times another y to the 9th. How many y's are being multiplied? 27. Okay, that's why this is the right answer. So if you're getting these really, really large numbers, go back and see if you're doing the problem correct. All right, we're at the 8-minute mark. I'm going to give you one more example. And again, you can pause. Okay, so try this example. Oh no, not in right mode again. Let's see here. Let's go with 18 over 54. And x negative 3rd, y to the 10th, I to the 12th, z to negative 5th, z to the 8th, the negative 1st. Okay, go ahead and pause. And when you're ready, you can see my solution. Okay, I'm going to go through this one a little bit quicker. If you're watching, I'm assuming you want to see what's going to happen. All right, so I'm thinking 1854, so I'm thinking that's 1/3. X to the 13th, y squared, and z to the 13th. That's the negative 1st. Get rid of the negative by flipping my fraction using the reciprocal, or as like Jaden Stormer likes to say, the refliprocal, and I'm done. Because anything raised to the 1st power is going to be itself, so I don't need to worry about the 1. There you go. All right, look at that. I set a record, 9:48. Mr. Lawrence signing out.